Welcome to Episode 2, where I try not to kill myself in the name of mathematics. You see, I used to skate pretty seriously. Emphasis on used to. That's me 15 years ago. This is me now. My body can't quite take the same abuse as it used to. But hey, anything for math, right? In this episode, we'll be writing a function. The input of the function, x, will be the number of pumps I take before jumping off the stairs. A pump is just a single push-off with a leg, like this. In this example, there are 4 pumps. 1, 2, 3, 4. So for this jump, our x value would be 4. The output of the function will be the horizontal distance I cover when I jump off the stairs. Here's how we'll measure it. The starting point will be the horizontal position of where I start to jump. The end point will be where I land. The f of x value then is the distance between the two. So, to summarize, input, number of pumps, output, jump distance. In order to measure the jump distance, I've marked off every foot past the base of the stairs. Since the width of the stairs is a constant 5 feet, adding the extra distance past the base will give us the total jump length. Let's collect some data, starting with 2 pumps. In order to accurately measure the position of the landing each time, I've decided to use the midpoint between the center of each of the skates. In this case, it's about 2.2 feet past the base of the stairs for a total jump distance of 7.2 feet. Now for the rest of the data, which we'll summarize at the end. So here we are. We can see that the jump distance increased with every new pump, but it did so at a diminishing rate, which makes sense. We certainly wouldn't expect a 100-foot jump with 100 pumps. That's because after a certain number of pumps, you've hit a max speed and you're not going to go any further. In fact, I would be willing to bet that I would not be able to make it past the 10-foot mark. Definitely not. And so that tells us something about our function. It needs to increase, but never pass 10, even if the number of pumps goes way up. Here's a function that does a good job. For 2 pumps, it gives a jump distance of 7 feet. And for 6 pumps, it gives a jump distance of 9 feet. Both of those are really close to what we need. And as the number of pumps increases, the value of this function gets closer and closer to 10 without ever going over. Let's take a look at a simulation. In this simulation, the number of dots, which is our input, x, represents the number of pumps. We'll set it to go from 2 to 6. The length of the line segment on the right is our f of x. It is a function of the number of pumps and represents the jump distance. We'll set it to -6 over x plus 10. Now we have a nice visual way to see the relationship. As we change the number of pumps, we can clearly see the corresponding change in jump distance. We can even investigate large number of pumps. If we change the maximum number of pumps to 20 and slide the slider, we can see that the jump distance approaches 10 but never gets there. So math has done it again. More proof that with a little thought and creativity, the universal language can be used to describe anything. So that's it for episode 2. I hope you enjoyed watching me almost kill myself for the sake of mathematics. Please subscribe to get these as soon as they come out. To use the simulations in the video, visit my website at harryo'malley.com and click on simulations. And don't forget, math is everywhere. See you next time.